is one of the grittiest jobs in construction, and one of the toughest.
We want to get all that out, push the pipe in.
For more than 8 hours a day, miner Dakota Hansen toils in virtual darkness.
We have to go up there and dig it all out, knock it off with the air hammer, and throw it back over our shoulder into that cart.
And he does it in the confines of a 4-foot diameter steel pipe, underneath an estimated 187 million pounds of stone, equivalent to 85,000 metric tons, known as the Salt Lake Temple.
Normally, we try to go about 6 feet a day.
Dakota is part of a crew placing 96 of these pipes that range from 20 to 40 feet long under the original foundation of the temple, accomplished 1 inch at a time, with this bucket that takes about 45 minutes to fill. Once emptied, it's back in the pipe for the bucket and Dakota. When enough earth and stone is removed, it's time to push the pipe into the area Dakota has mined. Hydraulic rams thrust this sled on tracks against the pipe and slowly push it into the hole with up to 2,000 pounds of pressure per square inch. The process is called jack and bore, a key component of the seismic upgrade system for the temple.
The jacking portion is the actual pushing of the pipe, and the boring, typically these are done with a large bore. In this case, we're actually doing it all by hand based on the accuracy that we need.
We tried to auger a few, and with the big rocks that we've come across, it's thrown it off.
Hand dug and hand measured.
We'll have a target up in front of the pipe, and we'll get the laser lined up. As we push the pipe, we're watching that target to make any changes with the pipe, if it needs to go up or down or left or right.
And why Dakota rides out the push inside to make sure that tolerance is met.
They've got to go in pretty much perfect every time.
The reason? These pipes tie into a very intricate system that secures the entire structure via cables, rods, trusses, and transfer beams, from the spires and roof to the reinforced foundation, to ensure the building moves as one solid structure in an earthquake.
The precision needed in the jack and bore process is very critical to a future component coming down from the roof, which is another set of post-tension cables that are actually being drilled from the top of the spires all the way down right in between these jack and bore casings.
The vertical drilling makes around a 5-inch hole through the temple stone that must pass dead center on a 7-inch gap between the pipes, comparable to threading a needle. Once the pipes are fully inserted, up to 32 of these valves or ports are installed along the inside of the pipe with this special modified cart.
Our specialty in this is literally pressure grouting.
Former pro golfer Paul Hammond says he uses skills from his former career to help with this job.
I was involved with the design and layout of certain golf courses up in the northern Utah area. Got to understand geology and how soils worked a little bit.
He said that knowledge came in handy trying to figure out the right flowable mixture of grout, which is a cement and sand-based slurry.
We've probably tried over, I would say, 8 or 9 different types of mixes.
That's important so that we can have that concrete very flowable through these types of soils.
The grout fills the area around the outside of the pipe, or the annular space.
We need to fill that or make it solid so we don't have a void between the old foundation and the new jack and bore pipe.
That allows the grout to be carefully pumped under pressure into the ports of the pipe and capped once they overflow.
Oh yeah, it's wrong.
The biggest challenge is making sure that everything goes smoothly and nobody gets hurt.
The next step requires some heavy lifting.
After that, we'll pull the valves out. They'll set a rebar cage.
This rebar cage is built off-site and hefted into place with a crane. These inserts add more strength to support the weight of the temple. These ducts inside the cage will eventually house post-tension cables to help suspend that weight.
We have cabling, and it's somewhat draped like this, and in the future when we tension it, it's actually going to lift up and put pressure up against the pipe.
The position of ducts for the cables are unique to each cage. Structural engineers spent years calculating their optimal positioning to meet the weight load of the temple.
That's because not all the temple weighs the same and not all stresses are equal. I kind of compare this to a trampoline that you're pulling stresses in every direction, and and it has to be balanced.
Once the cages are inserted, a cap like this will be placed on the exterior and interior ends before a secondary grouting occurs. In this step, grout is pumped into the steel pipe to capacity before being capped off. Once completed, the jack and bore process will bring the seismic upgrade of the temple one step closer to the next phase.
As we excavate down and get lower, we'll install a big heavy concrete footing, then the base isolators.
98 of these base isolators will rest below the jack and bore pipes and can support over 8 million pounds each, acting as bearings to keep the temple secure in a high magnitude earthquake.
And then on top of the isolators, we have the transfer beam that hooks the jack and bore system together.
The giant reinforced transfer beams will be placed in these openings of the temple for additional strength and support.
And all of that works as a whole system to create a new foundation for the temple. So it's absolutely critical part of that system.
All this stuff coming in here right now is key to actually holding up the temple after all is said and done.
It's one of the toughest jobs on site. Jack and bore crews dedicated to the difficult task. The historic implication is not lost on these men either, as they put in the long hours of labor to complete their part.
This is an icon of the world. We want to make sure that it does not move ever.
It's just a super unique project that we'll probably never see again.
It's a once in a lifetime opportunity.
And it really is an honor to be on it.